Hello guys, in this video I'm gonna cover indefinite integrals with you. This is calculus, past the calculus 2. So indefinite integrals. So let's say we have this problem to solve. So we want to find the general indefinite integral in this case here. This has two parts. This is the normal ones, basic ones that just requires you to add 1 to the exponent and divide by that. So this part would be pretty easy to solve. The other one is also easy. In this case, you have to use a conversion table that your instructor will provide to you, or you'll see in your book. So okay, the way we solve this, the way we get the integral here, the entire derivative. So what we do here, we break this down. We'll have 10. You can put 10 outside here, and you get the entire derivative of x to the 4 dx minus 2 entire derivative of secant squared x dx. Okay, so two parts here. Now this becomes very easy for you to do. For the first part here, all you have to do is 10 times, now this is like x to the 5th, add 1 to the exponent here, then you divide by what you have, so 5. Okay, so x to the 5th divided by 5 minus 2 times. Now according to the table, the conversion table, which you would learn this, by the way, you would pretty much memorize it. So the entire derivative of secant squared x is just tangent x. So that would be tangent x. Remember the 2 here, so tangent x. And since it's an indefinite integral, so plus c. All right. Then you can reduce the first part. 10 by 5 is just 2. So you'll end up with 2 x to the 5th minus 2 10x plus c. And this is your answer. Okay? Well, this is your answer for this one here, for this problem here, if I call it number 1, for example. Okay? So this is how you get an indefinite integral for a problem like this. Let's try another one in which sometimes you have a trigonometric expression that you will need to rearrange in order to see what you could get from the conversion table. Okay, let me show you an example like that. Let me show you this. Let me show you number 2 right here. Could be very easy. Again, it's not that bad, but you just need to know how to get there. So let's say you have to find the integral, so to evaluate the integral of cosine theta over sine theta, sine squared theta. Okay, so if you need to evaluate this one here, you will have to try to rearrange it first. Okay, so because this, you don't know it from the table, but what if we try to rearrange this? So we can rewrite this as, for example, 1 over sine. Okay, because we know what that means. 1 over sine theta. Okay, we can do this times cosine theta over sine theta. Now what we have here is the same thing we had before. Okay, we just split it. If we multiply this product here, we will still get the same thing. All right, so with this we can go further and actually write 1 over sine. What is 1 over sine theta? 1 over sine is cosecant theta. Okay, so we can write this as cosecant theta. And cosine over sine is actually cotangent theta. Okay, so cotangent theta, d theta, okay? And once you have this, you need to get the antiderivative of cosecant theta and cosecant theta times cotangent theta. So you know this, according to the table, is just minus cosecant theta plus c, okay? So this is the integral. That's how you get it, okay? So these are indefinite integrals. Now remember, it's not definite, it's indefinite. It's not, you don't get to an actual value. That's why you have the plus c, by the way. But in this case, what I showed you, so this was number 2, what I showed you from the previous example is that you can actually just, sometimes you have some general form, like basic forms, in which you just need to get with the exponents when you have polynomials. But when you have things included like trigonometric functions, right, then you will have to try to rearrange them and use the table to just get the value, the antiderivative you need, okay? So this would require you to memorize such table, because you would have to know whenever you see something like this, whenever you need to get the antiderivative of cosecant theta, cotangent theta, you would have to know that the answer to that is negative cosecant theta, okay? You would have to know that, okay? So that's why you would have to memorize this one, okay? For it to be easier for you to solve. All right, so this was indefinite integrals. Thank you.